All right, so recap 2, as I mentioned, I just split it up because it had a lot of words, and I didn't want to have too wordy a slide, but it's directly going off of the same lecture as the past slide. So let's go on. All right. Okay. Excuse me. So different changes can shift demand and supply. What do I mean by that? So remember that supply and demand are functions, right? You have a relationship between your quantity supplied and your price. That is supply. Your demand is a relationship between your quantity demand and your price. So this could look like you could have price equals quantity supplied times 6 plus 4, right? That is an example of a supply function. Okay, we can plot it, and it gives a relationship between every price and all the quantity supplied. Okay, it'll be a line in this case, and in most cases in the course, but it's an underlying function. Okay, if you change the price from, let's say it was 2, let's say the price was 2, what's the quantity supplied? So we just have to do the math. 2 equals, well, actually that'd be negative. 2 equals, negative 2 equals QS times 6. So negative 1/3 equals QS. So that'll be a negative example just because I did something at random. What if I said 10? What's your quantity supplied? Your quantity supplied will be, if P equals 10, it'll be QS times 6 plus 4 equals 10. So QS times 6 equals 4 equals 6. So QS equals 1. Okay. So given that I know the price, I can say something about the quantity. If I change the price to, let's say 14, what's the quantity? So again, we just have to solve it, right? It's just an equation. It's a function. QS times 6 plus 4 equals 14. QS times 6 equals 10. QS equals 10 divided by 6. So when I change the price, okay, and let's say this is my supply graph. Let's say it was the exact same one here. When I change the price from here to here, right, from like 3 to 5 or something like that, I'm shifting along the graph. I'm moving along the pre-existing supply graph. But there's another case, the case where for every price, my supply is changed, okay? So that'll be, for instance, let's say my supply has shifted. So supply shifts up by 4. What will the new supply graph look like? Well, it would be a change in the underlying relationship. So P is now equal to QS times 6 plus 8. Okay, this graph has shifted up by 4. So when P is equal to 10, okay, sorry, actually I did it down by 4. Because you want no, I was right. Supply shifts up by 4. Okay, I'm sorry about that. I was right. Supply shifts up, but a shift up is a shift inwards. Okay, it'll look like this, moving inwards, because the y-intercept will increase, which will lower the quantity for every price. But it's the same thing. Okay, so supply shifts up by 4, so the y-intercept moves up by 4. All right, and what does that mean for P? So when P equals 10, QS times 6 plus 8, so 10 minus 8 equals 2 divided by 6 would be 1/3. So the new quantity supplied is equal to 1/3. Is that right? Yeah. Okay. And then let's say P equals 14. Okay. QS times 6 plus 8 equals 14. QS times 6 equals 6. So P is now, QS is now equal to 1. Okay. So notice for the same prices, the quantity has gone down. okay? And it doesn't go down by 4. It goes down by, however much this shift will be. So like it's basically going down vertically, so the slope matters in this case. If it were QS times 1, then it would be exactly down by 1. I think it goes down essentially 2/3 for what it's worth for each one of these. Yeah. Anyway, and that's just because of the slope. The slope of 6. Anywho, so a supply shift is a movement of the curve, and let's just to clarify it graphically. So what happens when we have a demand shift? So I showed you this last week. So basically, this was a demand shift by 4. So for every price, quantity demand that is now increased by 4. Okay, you can see that from here versus here. I just added 4. You can see it even in the formula itself. So what does that look like? It's not going to be a shift along the demand curve. It's not going to be a move from this price point to this price point. It's going to be a whole nother line, a movement of the line itself. Okay. So if we're shifting up quantity by 4, okay, for every point, you're going to be 4 points over. Okay. And again, depending on the slope, if I said a shift up of demand by 4, it'd be a little bit different. Won't be exactly 4. Don't worry about the numbers right now. It makes more sense when you do it actually solving a problem versus just random examples that I'm throwing at you. So please don't worry about that right now. I don't want a question about, oh, what are the numbers in here? You'll see it when you see it, please. All right, so anyway, the shift of demand moved the whole graph. So when something became more popular, there was more people demanding it for every price point. That is a shift of demand versus when the price decreases, the quantity demanded will shift. That's a shift along the same demand curve because demand already has a relationship between price and quantity demanded. Okay, so for every price, the quantity demanded is different. Okay, if the graph moves, if the relationship between price and quantity demanded moves, that is a supply demand shift. Okay, and there are certain things that will shift your demand. Okay, and I'm going to denote them. So an outward shift of demand, a move from the yellow to the blue line, a move out away from the axis. I'm going to denote with a rightward arrow. Okay. So what are some things that could shift demand? If the people like the good more, if the good becomes more popular, if the preferences change in a positive way, that will shift demand out. Okay. So if I like hot dogs more, for every price, I'm going to consume more hot dogs. Okay. So where, let's say I find out that hot dogs cure cancer, and before at a price of $3, I would consume 2 hot dogs. Now for a price of $3, I'll consume 1,000 hot dogs if I know that it'll cure cancer. Okay, so I'll buy $3,000 worth of hot dogs. Okay, so people liking the good more will shift out demand. Okay, it'll move from left to right. Okay, let me even, for the sake of it, have a little demand curve and I can show you. So for demand, what goes on, or for any graph, what goes on the x-axis? You should answer to yourself right now, quantity. What goes on the y-axis? Price. What goes on the x-axis? Quantity. What goes on the y-axis? Price. What goes on the x-axis? Quantity. What goes on the y-axis? Price. What goes on the x-axis? Quantity. What goes on the y-axis? Price. What slopes downward is demand. Okay. Okay. So if I have an outward shift of demand, our new demand curve will be this guy a little here. I'm going to call it D and an apostrophe or D prime. Okay. So my demand curve has shifted from D to D prime because the good is more popular. Okay, for this particular price, I want more quantity demanded than I did before. I want more quantity demanded than I did before. I had it backwards. More quantity demanded than I did before. Okay, if the population increases, there's more people to consume the good. Okay, if there's more people consuming the good, for every price, you should expect demand to increase. Okay, so that'll be another rightward shift. If the price of a complement goes down, so if the price of bread goes down, or the price of like a roll goes down, I would consume more hot dogs because it costs less essentially to make a decent hot dog with a roll. Okay, if the price of ketchup goes down, I would consume more hot dogs because it costs less. So a complement is basically a good that you consume in tandem with the first good. Okay, so if I'm considering hot dogs, buns would be a complement to hot dogs, or ketchup would be a complement to hot dogs, or soda would be a complement to hot dogs. Okay, so the lower the price, or the more the price drops, the more I'm going to consume hot dogs. So the more the price drops on ketchup, the more hot dogs I consume. That's what it means to be a complement. Okay. On the other hand, if the price of a substitute goes up, the price of hamburgers go up, and I'm probably not consuming hot dogs and hamburgers in the same sitting if I'm paying for them, at least for me. Well, I'm a glutton, so maybe I would, but I'm a bad example. Let's say the price of kielbasa goes up. Okay, the price of kielbasa goes up, and you might have people who used to eat kielbasa, now they're eating hot dogs. Or the price of sausage goes up. People who used to eat sausage will now eat hot dogs. So the price of something else goes up, and those things compete with hot dogs, then you'd expect to eat more hot dogs. Okay. Likewise, let's say we're not talking about hot dogs. Let's say we're talking about streaming services. So the price of Netflix goes up. I'm going to consume more Amazon Prime. I'm going to be more likely to subscribe to Amazon Prime, basically. If you're confused on these two, I have that recap lecture that I'm going to cover in depth next week. But go through. I have some examples with the answer, whether or not they're complements or substitutes. And then I also talk about normal and inferior goods, which would be the next thing. But just go through them, see if it makes sense. For some people, you might say you might have different opinions on what's considered a normal or inferior good, or a complement or a substitute. Gave the example last week of Nutella and peanut butter, where people are like, no, I eat Nutella and peanut butter sandwiches together, which is weird. But I'll specify for normal and inferior goods. For complements and substitutes, I'm not going to specify. I'm going to presume that you can kind of tease it out because they'll be pretty straightforward. I'm not going to leave it up with Nutella and peanut butter like that. I might even specify, but don't bank on it. If you have any questions, like I said, go through the recap, the review slides for the midterm, and then let me know if they don't make sense to you. All right. Income goes up and you have a normal good. Your demand should shift out. What does it mean to have a normal good? A normal good is a good whose demand shifts out when you have a higher income. So this is what you call tautology, where I just explain the question, and then I defined and I explained the question using the definition of the question. But for a normal good is a good for whom or for which when income increases, demand goes up. I will tell you if something is a normal or inferior good, but most people will be able to suss it out using just logic alone, based on what you've seen. But for example, a normal good is most things you'll consume, and you'll contrast normal goods with inferior goods, which have the exact opposite definition. An inferior good is a good for which, when income increases, you'll consume less of it. So normal goods are things you consume more when you're richer, and inferior goods are goods you consume more when you're poorer. So an example of like an inferior good is like ramen noodles for like a college student, right? You consume a lot of ramen noodles because it's cheap and it'll sustain you. Hot dogs are probably an inferior good if that's like your main meal, if you're not like at a cookout or something. Um, One of the examples I gave in the review slides is like a fancy IPA would be considered a normal good. You're probably not consuming IPAs too much unless you have a substantial amount of like disposable income. But like you might drink a lot of Natty Boh or Natural Light or something like that. If you don't have too much money, like if you want to get your drinks in, drinking as a whole is probably a normal good, but maybe not actually. It should be a normal good at the very least. But particular drinks might be more or less inferior. So Natty Boh or Natty Light would be inferior goods because if you had your drudges, if you had the ability to choose, you probably wouldn't choose Natty Light. You're probably picking it because you're a poor high school student who doesn't have a whole lot of money and needs to sneak past their parents or something like that. Not that I'm saying I've ever done that, but yeah, you consume Natty Light because you don't have too much money to spend on Pliny the Elder or something like that, some fancy drink. Okay, Kraft mac and cheese might be an inferior good relative to some fancy Happy Rooster mac and cheese that you find in a nice restaurant with breaded crumbs and it's all nice and gooey. Kraft mac might be considered more inferior. It might also be considered more normal too. It's just things that you'd rather not consume, basically, but you're more or less bound to by income. Yeah. Expectation changes can also affect demand. I think this is really important for things like the oil market or stock markets. Not something I'm going to really stress in this class, but like I said last week, I kind of do want to just touch on it so that you know that it exists, but then you're not going to be tested on it. But expectation changes can matter. So I gave the example earlier of if you're in a market and you expect Amazon's price to increase twofold, or you expect Amazon to be worth $200 in a month, and it's at $100 now. You're expecting, basically what you're saying is people are going to profit off of holding Amazon shares. So what's going to happen? More people are going to want Amazon shares, and the price of Amazon will increase to basically price in the fact that people know that in a month it'll be 200. So if you expect Amazon to increase in price, demand will increase to match that, so that you can sell it later. And in like the real world, what happens is you end up in a bubble. The big bubble in like 2008 was based on housing prices. So people expected housing prices to increase with no end. So they were buying houses with debt, expecting that in 10 years you'll be paid off on your debt or paid off on at least a chunk of your debt, and you can sell the house for more than you bought it for. And that works for such and such amount of time until someone's like, oh, wait, this in 10 years there's no way that it's going to reach this price. So you know what, I'm going to lower my expectations of price. And basically, if people lower their expectations fast enough, the prices will drop in real terms. Like they're not just going to drop where you expect them to be. They're going to drop relative to what you bought them for. And that's what caused this idea of a bubble. And basically people who debt financed housing, expecting that in 10 years they'll be able to make money on the houses, no longer could. So expectation changes matter. Likewise, there are supply shifters. Okay, and sorry, expectations matter, and basically if you expect the price to increase, demand will increase, and if you expect the price tomorrow to decrease, then demand will decrease. Okay. Supply shifters are similar. So I'm grouping these two together because I realize I'm going kind of long on this. But technology progresses. And technology progresses, that should say progress, and input prices decreasing. They both kind of say the same thing. As the cost of supplying something decreases, your supply should shift outwards. Okay. So what goes on the y-axis? Price. What goes on the x-axis? Quantity. Which does supply shift upwards or downwards? Upwards. Okay. So if I expect my costs to go down, or if my costs do go down, basically, then I should be able to supply more, and more suppliers should enter the market. Okay. Remember that supply is basically a map of marginal cost. So if the marginal cost decreases, if the cost of producing units decreases, then the supply will shift outwards, basically. The lower the cost, the more people the more suppliers can afford to produce in the market. So the more suppliers that there will be, the higher the quantity supplied. Okay. Industry size increases for the same reason. If there's more suppliers, then there's going to be higher quantity supplied. And then this one I don't especially love for supply, particularly after the slash. But if you expect supply to change in a year, again, this matters kind of like for oil. So if you expect in a year that there will be less oil produced for whatever reason, you might decrease your supply now. You might shift it in, so that you more or less have a consistent amount of supply through this year and next year. Related output price changes, I'm not even going to cover again. I talked about it in the first lecture, but I do not really like it because I think it causes more confusion than it's worth. But basically, like if you expect a substitute good to increase in price next year or increase in price now, you might increase your supply basically, or decrease your supply, hoping to capture market share or hoping to capture higher prices. It's really not worth covering. It's really market dependent, and I don't want you guys thinking about it because it's kind of a second order effect. It's like something that happens after the fact. And it's not even real clear. I don't want to cover it anymore, and I regret the time that I've spent just covering it right now. Okay. Let me erase this so you can read. Boom, boom, boom. Well, so be careful to understand when supplier demand shift. That means you have a shift of the underlying supply and demand function, which is a function of price, or which is a relationship between price as a function of quantity, and that has changed, right? So by that I mean this shift happened for the whole price quantity relationship. The shift from D to D prime means that for the same price, you're going to have different quantity demanded. Okay, and I contrast this, and I can't contrast it enough, with a shift along the same curve. So if you're going from this point to this point, A to B, prices changed, which led to a change in quantity demanded. Okay, but from A to C, the price is the same, but quantity demanded is different. The relationship between price and quantity demanded has changed. And that's the whole point of these shifters. They change the underlying function. Okay. And I've already talked about this, and I talked about it again, so I'm not going to spend any more time on this.